Hello everyone. So you are again welcome in my lecture series on digital signal processing. Today we will study time shifting property of Z transform. So before explaining the time shifting property of Z transform, what do you mean by time shifting of a signal? So first we'll understand time shifted version of a sequence or a signal x of n. X of n is a sequence whose values are 1, 2, 3, and let this sample value 2 is corresponding to n equals 0, and this is corresponding to n equals minus 1. The value 3 is corresponding to n equals 1. This is our sequence. We can draw this sequence. So values are 1, 2, and 3. These are the values 1, 2, 3, and this is our n. So this is corresponding to minus 1, this is corresponding to 0, and this is corresponding to 1. This is the sequence x of n. Now if I ask you to find x of n minus 1, what operation you will perform on the sequence? This x of n minus 1 is the shifted version of xn by one sample in forward direction or in right hand side. Or I may ask you to find x of n plus 1. This x of n plus 1, this is also a time shifted version of xn, but this time xn would be shifted in backward direction or in left hand side direction by one sample. So time shifting does not change the sample values. It simply shifts a sequence in right hand side or in left hand side by the given number of samples. So in general, if I write x of n minus n naught, this x of n minus n naught, this is time shifted version of xn. And if n naught is positive, then we shift the sequence in right hand side direction. And if n naught is negative, then we shift the sequence in left hand side direction or in backward direction. So if I try to draw xn minus 1, what would be this xn minus 1? So if we are trying to find x of n minus 1, means we are shifting this sequence in right hand side direction. So this value 1 which is occurring at minus 1, this will shift at n equals 0. This value which is at n equals 0, that will go at n equals 1, and the value which is at n equals 1, this value 3 will go at n equals 2. So what would be x of n minus 1? So there won't be any change on these values 1, 2, 3. But the earlier in xn, this 2 value was corresponding to n equals 0. Now this 2 value will be corresponding to now n equals to 1, and the value 1 which was corresponding to n equals minus 1, that will become value corresponding to n equals 0. So I should place this arrow here. So this is corresponding to 0, this is corresponding to 1, and this is corresponding to 2. So if we draw this sequence, let me draw this shifted version in blue. So what has happened? So values remains the same. Values are 1, 2 and 3. You can see there is no change on the values, but this minus 1 has shifted to 0, 0 has shifted to 1 and 1 has shifted to 2. So this blue sequence is x of n minus 1. Similarly, if I ask you to find x of n minus 1, what will happen? You will shift this sequence xn by one sample in backward direction, and therefore what will happen? The value which is at minus 1, which is 1, this value 1 will go at minus 2. This value 2 which is at 0, that will go at minus 1, and this value 3 which is at 1, this will go at 0. So what would be our sequence? Our sequence xn plus would be like this. The values are same 1, 2, 3, but what is happening? This value 3, that is now corresponding to 0. So I shall put the arrow here, and this is corresponding to n equals 0. This is corresponding to n equal minus 1, and this is corresponding to n equals minus 2. So this is the time shifting of signal. Time shifting means shifting the sequence in backward or forward direction by given number of samples without affecting the sample values. So what we can say, how to shift any sequence. Suppose a sequence is given to you, any sequence is given to you. This is the sequence. Let's say this is 1, this is minus 2, this is 3, and let's say this is 1.5. This is the sequence xn. And now I ask you to obtain the time shifted version x of n minus 2. So what you will do? And let's say this is corresponding to this sample value 1 is corresponding to minus 1. This is corresponding to 0. This value 3 is corresponding to n equals 1. And value 1.5 is corresponding to n equals 2. Now we have to draw xn minus 2. So what is the trick? How you can draw directly xn minus 2? As I have explained that there won't be any change on these sample values. There will be change only at n. There would be change only in these sample indices. So now because here n naught is positive, the sequence would be shifted in forward direction by 2 samples. So here I write, what I shall do, I will add in all these time indices 2. So this minus 1 will reach at what? This will reach at 1. This 0 will reach at what? 2. This 1 will reach at what? 3. And this 2 will reach at what? 4. So now if I remove this minus 1, 0, 1 and 2, and instead I write here what? 1, 2, 3 and 4, and this is now my new n. Then this would be what? My xn minus 2. So this red time indices are corresponding to what? Corresponding to sequence x of n minus 2. Similarly, if I ask that you draw the sequence x of n plus 2, then what you will do? In that case, here now n naught is minus 2. So you will subtract from all these time indices 2. So what will happen? This minus 1 will reach where? At minus 3. 0 will reach at minus 2. 1 will reach at minus 1. And this 2 will reach at 0. So these green time indices are corresponding to what? X of n plus 2. So you need to change only this time indices. There won't be any change on the values of xn. So this is the time shifting of a sequence. Now we come to the business, that is time shifting property of Z transform. So what is the time shifting property of Z transform? Let us assume our sequence is xn and its Z transform, let it be x of z with ROC R. Then if I shift this sequence by n naught samples, then what would be the Z transform of this shifted version? It would be x of z, z to the power minus n naught. And what would be the ROC? The ROC, let us assume it's R dash, it would be almost R. Now I am saying, why I am saying it is almost R, because I first, let me write R dash is R except possible exclusion or inclusion of z equals 0 or z tending to infinity. What does it mean? It means when we shift the sequence, the Z transform will, the expression of Z transform will multiplied by Z to the power minus n naught. And what would be the effect on the ROC? ROC will remain R. There may be possible change, a very small change, minute change in the ROC. And what change it is? There could be exclusion or inclusion of either z equals 0 or z equals infinity. Why? We will see through examples. Now, before taking examples on time shifting property, let us prove this property. Now we know what is the definition of Z transform. It is summation over n running from minus infinity to plus infinity xn z to the power minus n. Now we have to find Z transform of x of n minus n naught. So what would be its Z transform? Its Z transform would be summation n running from minus infinity to plus infinity x of n minus n naught z to the power minus n. Now here in this summation, I make a change of variable and let us assume n minus n naught is m. Then what would be this summation? Now this summation would be over m. Now if n is minus infinity, m will also minus infinity. And if n is plus infinity, m will also plus infinity. So n minus n naught is replaced by m, and this z to the power minus n, this will be replaced by m plus n naught. So if I further simplify this expression, what I get x of m z to the power minus m. And now this summation is over m. Therefore, I can take this term z to the power minus n naught out of the summation. And this summation x m z to the power minus m, what it is? It is x of z. So I can write this is equal to z to the power minus n xz. So we have seen that the Z transform of time shifted version would be x of z, z to the power minus n. Now we shall take some example on time shifting property of Z transform. As we already worked out Z transform of unit impulse, and what was it? The Z transform of delta n was 1 and its ROC was entire Z plane. So let me call this as my xn and this as my x of z. Now I can also draw this delta n. This is 1 at 0 and 0 elsewhere. So this is delta n. Now if I ask that find the transform of delta n minus 1 using the time shifting property. So before finding the z transform, can we draw this sequence delta n minus 1? We know that n naught is 1, so delta n would be shifted by one sample in forward direction. So the value will remain 1, but this 1 would occur at which n? It will occur at 1 and it is 0 elsewhere. So this is my delta n minus 1. Now can we use the property, time shifting property? So we just saw that if xn z transform is xz with ROCR, xn minus n naught z transform would be what? Xz z to the power minus n naught, and ROC would be what? R with possible exclusion or inclusion of z equals 0 or z tending to infinity. So let us see what happens for this sequence delta n minus 1. So our xz is what? 1. And what is our n naught? N naught is 1. So xz 1 multiplied by what? Z to the power minus n naught. And n naught is what? Minus 1. So we get what? We get z inverse. Now, what would be the ROC? Will it entire Z plane? No, we can see that this is 1 upon Z, and if Z becomes 0, this would become infinite. So, there would be the exclusion of the point Z equals 0. So, we can write entire Z plane except Z equals 0. So this is the Z transform of delta n minus 1 using time shifting property. Similarly, if I ask what would be the Z transform of the sequence, let's say delta n plus 1. So again, we can make use of time shifting property. Xz is 1 multiplied by, now our n naught is minus 1. So minus minus will become plus. So this is the Z transform of delta n plus 1. And what would be the ROC? Will it entire Z plane? No, it would be entire Z plane except with one possibility. Except what? Except Z tending to infinity. So we have seen that this fact, why I have written that ROC is almost same except the possible exclusion or inclusion of the point Z equals 0 and Z tending to infinity. Now take one more example. In starting we took this sequence xn equals 1, 2, 3. We started with this sequence and assume that this arrow is placed here, means this sample value is corresponding to n equals 0. And we have already worked out z transform of this. Again, if we try to find out z transform of this, this would be summation from minus 1 to plus 1 xn z to the power minus n. So can I write the z transform of this? What it would be? It would be z plus 2 plus 3 z inverse. And what would be the ROC? There would be the exclusion of z equals 0 because of the term z inverse, and there would be exclusion of the point z tending to infinity because of the term z. So what is the ROC? ROC is entire z plane except what? Z equals 0 and z tending to infinity. Now, if I ask that use time shifting property and find the Z transform of x of n minus 1. So what would be x of n minus 1? This would be the time shifted version of xn by one sample in the forward direction. So 1, 2, 3, and now this arrow comes here, and now we use the property without using the definition of Z transform, rather using the time shifting property. What would be the Z transform? Xz multiplied by what? Z inverse, because we are shifting the sequence in right hand side direction. And what is our Xz? Our Xz is this Z plus 2 plus 3Z inverse multiplied by Z inverse. So what you get now, it is 1 plus 2Z inverse plus 3Z to the power minus 2. And what would be the ROC this time? This time you can see that Z term has been disappeared. So ROC is entire Z plane except what? Z equals 0. Now there has been exclusion of the point z tending to infinity. In the previous case, means when the sequence was xn, both the points z equals 0 and z tending to infinity were not there in the ROC. But when we shifted the sequence in right hand side direction, we have seen that the point z equals infinity has now been included in the ROC. Now, similarly, if I ask what would be the Z transform of x of n plus 1? So, what it would be? It would be x of z. Now, this time multiplied by z. So, what it would be? It would be z square plus 2z plus 3. And if now I ask what is the ROC? Again, the ROC is entire z plane, but there is an exclusion of one point, except z tending to infinity. So now we are seeing that in original xn sequence z transform, both the points were excluded from, both the points means z equals 0 and z tending to infinity were not there in the ROC, but in the ROC of xz into z, this point z equals 0 is included, and only point which is not there in the ROC is z tending to infinity. So this is the time shifting property, and using this time shifting property, we can also find out Z transform of some other important sequences. Now take one more example. What we know already know this sequence Z transform. What is Z transform of UN? If you remember, we worked out Z transform of alpha to the power n un, and it was 1 upon 1 minus alpha z inverse with mod z greater than mod alpha. Now, if I take alpha 1, then this will become what? Un. And what would be the Z transform of it? 1 upon 1 minus z inverse mod z greater than 1. We know the Z transform of unit step sequence. And unit step sequence, how we defined it? It was 1 for n greater and equal to 0, and it was 0 for n negative. Now, if I shift the sequence, if I find u of n minus 1, so what it would be? It would be 1 for n minus 1 greater and equal to 0, and it would be 0 for n minus 1 less than 0. So you can see that now the sequence would start from 1. It will start from 1 means non-zero values would be 1 from n equals 1 onwards. So what is the Z transform of u of n minus 1 using the time shifting property? So again, recall the time shifting property. What it says? It says xn, if xn Z transform is x of z, x of n minus n naught, Z transform would be x of z, z to the power minus n naught. If the ROC of xz is R, ROC of xz into z to the power n minus z to the power minus n naught would be what? R plus minus something. And therefore, I am writing like this, plus minus something. And that's something you already know. Exclusion or inclusion of these 2 points, z equals 0 and z tending to infinity. Now, u and z transform is known to us, 1 upon 1 minus z inverse with mod z greater than 1. And u of n minus 1 z transform would be what? You multiply xz by z inverse. So z inverse 1 minus z inverse. And if you simplify this expression, what you get? You get 1 upon z, then 1 minus 1 upon z. So you get 1 upon z minus 1. And again, now there won't be any change in the ROC this time, and mod z is greater than 1. So what you have to remember, that if the sequence is infinite duration sequence, and if you shift the sequence either in left side direction or right side direction, there would be change in the expression of Z transform, but the ROC will remain same. The ROC changes only in case of finite duration sequence. So with this, I stop here. Thank you very much.